Okay, so this video is going to cover the first example for week 8's lab. First of all, I suppose we'll break down the information given in the question. So given is a plan of a tetrahedron, as seen below here. An oblique cutting plane, 30 degrees to the horizontal plane, is cutting through the object. Okay, so we have our object here. We have a cutting plane which is cutting through this object, and it's cutting through it at 30 degrees. Now we don't know at what angle it's coming from. We know that it's 30 degrees from the horizontal plane, but we don't know what angle it is to the vertical plane. So for instance here, we don't know if it's in this orientation or this orientation or this orientation yet. So if we look at the question again, A and B represent two corners of the cut surface, so A and B here. So they represent two corners after the surface has been cut by this cutting plane that's coming in. A and B are closer to the horizontal plane than the other corner. Okay, so A and B here are close to the horizontal plane, so that means that they're lower to the ground itself, so the actual floor, let's say, which the object is resting on, than the point, our last point, and our last point will be going through this line over here. So we know now that our 30 degrees is going to be coming somewhat from this angle. Okay. Also, the question asks us to draw the traces and complete the plan and elevation of the cut tetrahedron. Now, before we do any of that, what we need to do first of all is draw our elevation of our tetrahedron before it has been cut. One issue that we're going to hit off of when we start bringing it up here is we won't know how high up from the horizontal plane in elevation. So the horizontal plane is the XY line here in elevation. We don't know how far up this basically apex is from that ground. So to do that, what we need to do is take an auxiliary view of this. Now the auxiliary view we're going to take is going to be parallel to either one of the three lines here, which I'm just going to call this 1, 2, 3 and 4. So it can either be parallel to 1 and 2, the line 3 to 2, or 4 to 2. If we have an auxiliary view that's parallel to any one of these, like so, what we can do from that is get an auxiliary elevation, and from that auxiliary elevation we can use the line that we've taken parallel to. We can now take that as a true length and then find our location, or basically the height of 2 from the horizontal plane. Okay, so I'm going to do that now. Now the one that I think is the handiest to take here is line 1 to 2, just ensuring that I keep it away up out of my drawing itself. So I'm going to carry it way up out here, out of the way. Call this my X1, Y1 line. Now I'm going to take all my lines perpendicular to this line here. I know because of tetrahedron that my baseline here is going to be perpendicular to its opposing line. So I'm going to take 4 and 3 up to hit the XY line, X1, Y1 line. I'm going to take 2 up, but I'm going to extend because it's going to be above it, the horizontal plane. And I know 1 is going to be lying on the horizontal plane, so I know it's going to be on the X1, Y1 line here in my auxiliary elevation. So this is going to be okay. Now to complete my auxiliary elevation, what I can use now is my true length. I know my true length because I'm looking parallel with this line here. That is going to be a true length now above here in my auxiliary elevation. Now to get the length of my true length, to get the length of my line above here, which is going to be a true length, I need to find a true length down here in my tetrahedron. Now because I know my tetrahedron is lying on the horizontal plane, I know that any one of these lines, 1 to 3, 3 to 4, or 4 back to 1, is the distance that I need to take. Now you also need to have an understanding of how to construct a tetrahedron and all the factors that define tetrahedron to know this information. So I'm just going to take one of those distances from 1 to 3 here. Then I'm going to go up here where I have 1, and I want to find 1 is to 2, which I know is going to be a true length above here, so I can take that distance, knock it off, and now I have my apex and my height of my apex above the horizontal plane. Now what I have here is basically the shape itself for the tetrahedron constructed above in my auxiliary elevation. This surface here is representing this surface. The surface back here is actually directly behind this surface, and my surface here is actually represented as an edge view, which is traveling down from 2 to 4/3 here. Now what I can do, that I have this height, I can construct it here, my elevation. Taking my height that I found, knock it off. Now that I have my tetrahedron complete, my elevation, what I need to do is start finding my traces. I have to find my traces, basically showing the cut section of the tetrahedron itself. Now, to find the traces, what we need to do, because we have the angle at which this cutting plane is at, as well as we have 2 points that are basically on the cutting plane itself. So what we can do is take A to its location elevation. That's going to be A here. It's going to be B. So now that I have A and B, what I can do is use my 30 degrees here and construct a cone. Now what the cone is going to do is provide a surface that basically my cutting plane is going to be lying against, because we know the cutting plane is at 30 degrees. We also know that it hits at these 2 points. So if I construct a cone here and a cone here, I can use the base circles of them down here in my plan to draw a tangential line to find my vertical trace. Now this construction was actually used before, when you were doing your internal and external tangential planes to a cone and a sphere. So I'm going to get my 60/30, so I don't need my set square or my protractor. If it was a degree that I couldn't find using my set squares, I'd use my protractor. That I have my 30 degrees handy here. All I have to do is construct the side of one of my cones, like so, for A and for B. Take a parallel line from A and B to the XY line, like so. So bringing them down. And then I have to construct my base circle. Now I only need to really construct a portion of it, just to find where I can draw a tangential line to the two of them. Like so. And my second one. Like so. Now what I can do is I can line up a straight edge against these two curves. Now you can use a construction to find out basically how to draw a tangent to two circles. For this I won't be too worried about it, just line up your straight edge the best you can. And draw a line till it intersects the XY line, which you're going to mark as T, and H below here for your horizontal trace. Now what we need to do is find your vertical trace. To do that we also need a point that is above the horizontal plane, that is also where the horizontal plane is going through. So we can either take A or B. I'm going to choose to take A, and I'm going to make sure that it's parallel to the horizontal trace. Take A over, take it perpendicular to the XY line, carry carry A across, where that intersects is the point on the VT, vertical trace. All I have to do is draw a line from my T through that point, put V up here, and that's my vertical trace. So I have this section completed, half my question. Now to finish it off, I need to find out, or to draw the elevation plan of the cut tetrahedron. To do that, I can extend my horizontal trace, like so, out this direction. Draw a line perpendicular to that, up here out of the way, to take an auxiliary view. When I'm looking at this auxiliary view, what I'm doing is I'm looking at the cutting plane as an edge view. So I know that my cutting plane is at 30 degrees, as above here, says above here in question. My protractor, 30, draw a line from here up. T, this is V. Take all the rest of the points that I need up. Remember, this is the first auxiliary as well, x1, y1. All the points are going to be resting on the x1, y1 except for point 2, which is the apex. Take my height either from my auxiliary elevation above here or my elevation here. Remember, what you are doing is you're standing in from here and looking in. So this is the edge of the plane as you're looking in here. You're seeing this line here, your HT, as the 1 point. So this is H/T. So you're actually seeing this line here as a point view. And you're seeing the vertical trace in on the side. So what we're going to be doing is like standing here. So you can imagine all the lines here out in front are going to be the ones we can see. So we have our 4, which is here, our 1, which is here. This is going to be 2, and this is going to be 3. We'll be able to see 2 to 3. We'll be able to see 4 to 2. We won't be able to see 1 to 2, so I'll just put that in as hidden detail. Now again, I'm having it fairly dark here so you can see everything that's happening. Most of this is going to be construction, so keep it nice and light. Now we can also identify the points at which the plane is cutting through the surface. Now if we've done this correctly, if I was to take A up parallel to the horizontal trace, as well as B up to the horizontal trace, it should intersect at the same point as it's indicated above here in our auxiliary. Now to prove that, what I'm going to do is just line it up. Now depending on the inaccuracies, it might be a small bit off. B here, as you can see, as it travels all the ways up, it lines up with the corner it should. Same with A. A also lines up with the corner that it should right there. Now the one that we're missing, we have to bring that one down, which we're going to label C. Carry that back, and now we've it located here. So we can join C to B and C to A and A to B. Now we have A and B in our elevation, so we just take C up, C, and we can join B to C, C back to A, and A back to B. Now remember, it's important to highlight what the remaining surfaces So if you want to use a black marker or something like that to go over it, now you should have the construction fairly light anyway. And that's the question completed.